Hello, I'm Prof Arup Kr Sarma from Civil Engineering Department of IIT Guwahati, and my research scholars working with me, we are working on various topics, but one of the important topics that we are working is river modeling. See, river is always very close to us and we are getting a lot of benefits from river. At the same time, we are also suffering because of the flood and erosion problem, particularly in large river like Brahmaputra. And that's why we need to understand the river flow characteristic very well. And when we apply various model, in fact, we have our own model, Brahma that we call, that is Braided River Aid Hydro-Morphological Analyzer. So this is one model. Similarly, we have other models also people are using. Now, when we apply this model, we get the average flow velocity at a particular section of a river or at a particular point of a river. Okay. Now, sometimes in braided river like Brahmaputra or large river, what happened that undercurrent is very fast and we need a three-dimensional model for that purpose, but for large river having a three-dimensional model is very difficult. So what we did, we developed a quasi three-dimensional model by applying entropy theory on the Brahma model. What we were finding that we can develop how the velocity varies along a vertical direction. That is, the velocity will not be highest on the surface. It will be at a certain depth. Sometimes it can be 0.5, or half of the river flow that depth can, velocity can be maximum. Sometimes can be it is slightly higher than that. So that way, at what point we can have maximum velocity, that we can calculate. So that's what the beauty of this particular model. And this is important because suppose in high flow period in monsoonal time, we cannot go to the river and measure the velocity. So what we did, that was of course high period in say October kind of things. We measured the velocity near Majuli Island and we could find how the velocity is varying along a vertical, and then we applied our model and we could find that our model is in good agreement with the experimental or field-based result. So that way we presented that in the journal of ISH, that is Indian Society for Hydraulics, that's an international journal, and the paper was published there, and among all the paper it was just as the best paper, and that's why they have awarded us this particular Puraskar. They call it Jal Vigyan Puraskar, and I'm happy to share this award with my student Dr Anupal Barua. So its applications can be quite diverse. For example, when we design a spar, then spars are mainly failing because of the erosion of the bottom part, and because we do not understand how much will be the velocity at the bottom, how it will cause the erosion or scouring part. So now with this model we can find out those things in a better way. Then another application can be, say, we are applying vegetation for solving the bank erosion problem, which we call as the bioengineering method. That also we have applied in Majuli recently. Now in finding if we put a vegetation, then how this kind of flow velocity will be changing. Our further research is going on in that direction, and some more students are working in that, and we are very successful in that direction also in finding that. Another third example I would like to give, that fish, as you know, the aquatic life, fish, some fishes live in a lower depth, some fishes live in a higher depth. This is not just because of the depth. It is because of the velocity, because some fish can withstand high velocity or they like to stay there. So that way, nowadays that ecological importance is increasing. So when we apply this model, suppose, then we can find out where, how much velocity will be existing and which will be having a suitable habitat area for the fishes. And because now with various structures being coming up, we are augmenting the river flow for our benefit. In that case, how the velocity is changing and whether it will be suitable for other aquatic life in the whole river. So that also we can check by applying this kind of model. And this research was done in collaboration with Brahmaputra Board and Ministry of Water Resource, Jal Shakti Ministry was also associated, and particularly they were helping us in the field study in collecting data, and my student and I was personally there, of course in a risky position in collecting all this data, but then that data we collected very sincerely, and then model could be validated well with this data. It is always very inspiring that this award is being given. It always inspires me, my team, the research team, research scholars, and the institute to do more and more work in that direction. And this is definitely going on. It is always an ongoing process, and it will keep on going to do good work for the people. And I mean, our institute is always committed to do good for the people. So that's all. Thank you very much. Thank you all.